In this video, we'll create two simple workflows in one notebook. The first one is the sphere cube, created from primitives in nTopology. In the second workflow, we'll bring in a CAD file of a gear, shell it, and then add in some escape holes. For the sphere cube, as the name suggests, we'll need to grab a cube block and a sphere block from the Create tab. Let's rename this section Sphere Cube. We want to place the sphere at one corner of the cube, so we can do this by clicking into that center point input and moving the object to our desired location. We could also type in the location into the input to be more precise, but if we at any point in time change the size of the cube, the sphere will not come along with it, because we haven't established any sort of dependency between the two objects. To do this, we have to go into the property panel of the cube and then select a property chip such as the max point or the min point and drag that into our center point input of the sphere. Now if we change the size of the cube and click out of it to compute, then the sphere will come along with it. We could also make sure that the ratio of the size between the two objects stay the same. For example, having the radius be half the size of the cube. And to do this, we can type directly into that input, divide, to grab the math block. And then for the operand A, use the size of the cube. We'll rename it to cube size. And then put it into operand A and divide by 2. Now, no matter what size we change it to, the ratio will stay the same. Let's now change the display color of the two objects. And then we'll merge them together using the Boolean union block from the Modeling tab. And we can just grab those two blocks and drag into the bodies list in the Boolean union block. Add a blend radius of 2, and then we'll also make this a variable and call it sphere cube. If we isolate the cube that was the original primitive that we made, we can see that the color is pink, and isolating sphere, the color that we just changed it to is green, is still there. This is because nTopology doesn't delete anything that we've created. So with any new operations that we're doing with objects that we've created, we are adding another object to the notebook. We'll now collapse this sphere cube block and turn off its visibility, and then add a new section called Gear to start our new workflow. The first step of this workflow is to import our part by dragging and dropping it into the instance. The part isn't visible on the screen right now, so we can press Z on the keyboard to bring it into view. We'll then double-click on the part to select the whole body, then right-click and choose Convert to Implicit Body. We'll rename this variable gear. And since we don't need to work with any of the parameters in these two blocks, we can collapse them. Now, to shell this part, we need to grab the shell block from the Modeling tab. We'll drag in the gear implicit body as the input, and we'll use a thickness of 1 millimeter in the inward direction. If we isolate this shell by pressing I on the keyboard with block selected, and then press X to see the section cut, we can see that we now have this gear part that is shelled out. So we can go to the block, right-click, and make this a variable, and name it shelled gear. Next, we'll add holes on this top surface of the shelled gear. To do this, we'll create a series of cylinders, which we will then use to Boolean subtract from the shell we've just created. So we'll grab that cylinder block from the Create tab, and we can play around and change the location of it by clicking into each input and then using this gimbal to drag the cylinder to the location that we want. Let's also change the radius to 2 millimeters. And we can keep adjusting point 1 and point 2, which are the start and end points of the cylinder, until it's at the position we want. Then clean up these numbers a little bit. And now to repeat the cylinder about the center of this gear, we will use the polar array body block from the modeling tab. And I will put in 9 counts with 40-degree angular spacing between each body. Then define the axis by double-clicking into the axis input and select axis. And we don't have to do anything here, because if we turn on the visibility of that axis, we can see that it's already at the center where we want the cylinders to revolve around. So we can go ahead and right-click on the polar array body block, make it a variable, and call it cylinders. Then we'll grab that Boolean subtract block and bring in our cylinders as the subtraction body that we will subtract from the shelled gear, the primary body. And now we've created those holes, but we also need to make sure that these cylinders aren't also subtracting away any other parts of the shell other than where we want those holes. So we can adjust the length of these cylinders to be a little bit shorter and maybe with a smaller radius. We can make this radius a variable as well if we want to be able to come back and easily change their size, and we can call this radius of holes. And since we now have our shelled part with the escape holes, we can go to that Boolean subtract block, right click, make it a variable, and then call this final part. If we want to, we can quickly check the percentage weight savings achieved with this workflow by going to the lightweighting tab and adding this weight savings block to the notebook. All we have to do is bring in our final part as the lightweighted body and grab the initial gear implicit body for the original body. And this tells us that this workflow reduced the weight of our part by 58.8%. If I want to be able to see the before and after side by side, I can go to the Utilities tab to transform and bring in this Translate Object block. I'll right-click on the final part block and choose Remove Variable Contents. Drag that content into the Translate block and give it a vector value. In this case, I'll move it 50 millimeters in the positive Y direction, and then press Enter to compute. Then drag all of this back into the final part variable. I can go back and find my initial gear body, turn on its visibility, and also collapse all these blocks to better be able to see the whole workflow. And the two parts can now be seen together side by side. If we for some reason want to fill the holes back in on the final part, or want to use the fillings of these holes in another workflow, we can Boolean intersect together the shelled gear and the cylinders. And this will show up where we have the initial part. So to move these fillings to where the final part is, we can again use the Translate Object block, and we'll grab it from the search bar this time. We'll use the same translation vector as last time, so we can go into the final part block, make that vector into a variable, which I'll call Translate Vector. We'll bring that into our new Translate block and also drag in that Boolean intersect. Now we can right-click and make this whole thing a variable and rename it Hole Fillings. I'll isolate this block to only see it at the new location, turn the final part's visibility back on to check, and the fillings are now where the holes are. Let's turn the visibility of the original gear back on, and pressing X on the keyboard, we can look at the cross-section of both bodies at the same time.